Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. Why PFC circuit is used in switch mode power supply in any SMPS. I repaired this power supply in my last video and I detected that MOSFET in PFC section and this PFC controller IC is damaged. I turned on this power supply without PFC because I detected the problem. So I am waiting for the components for this power supply. Other circuit is working now normally. I received comment from my viewer that will this power supply work without PFC? To address this question, we will discuss in this video that why we need PFC. If we see this universal power supply, it is providing 5 volt 2 ampere. If we see this power supply, it is providing 12 volt 20 ampere. Difference in this power supply and this power supply that we apply 85 volt to 265 volt. So this power supply will produce 5 volt 2 ampere with this large variation in the voltage from 85 volt AC to 265 volt. It will provide regulated output with minimum load or with maximum load. If we see this power supply, line input, EMI filter, bridge rectifier, capacitors. Here is a selector switch 110 220. If you are operating this power supply in 220 volt utility line, that time this switch will be selected at 220. If we are operating in 110 volt condition, that time we will select this switch to 110. So it is manual selection. Why we need this switch? Because we are taking approximately 250 watt output, 12 volt 20 ampere. At that time we need some regulated voltage on this line. Basically this switch makes series and parallel these capacitors. I already shared a video why this selector switch is used. You can watch that video as well. The number is displayed on the screen. Today we will see why PFC is necessary in this power supply. First we will analyze the function of power supply and then it will become easy to understand the function of PFC. Line voltage 50 Hz or 60 Hz whatsoever. After EMI filter, these voltage are provided to bridge rectifier. We will receive positive, negative. Here were AC voltage, but now DC voltage. We receive rectified voltage here at capacitor. It is DC rail. This smoothing capacitor, that is this one, then these voltage are reaching to transformer winding. At the second end of transformer winding there is a switching device. Might be it is transistor, MOSFET, IGBT. Emitter or source are connected to ground and there is a drive signal here. This drive signal comes from this PWM controller. It will switch. When it will switch, it will allow current in this transformer winding. In result, we will receive output voltage in the secondary. This is our output area. In SMPS, we need regulated output. A portion of the output voltage is connected to a reference regulator. Might be it is zener, adjustable zener. It will drive optocoupler. When the voltage will maintained at output, it will allow a switching to this LED, IRED, that is part of optocoupler. This optocoupler will provide feedback to this PWM controller. TL431 or any zener, anything that will sense the voltage. Now this is our feedback loop. When voltage are maintained here, if there is load or no load. For example, we need 5 volt. When the voltage will drop from 4.95 volts, it will give feedback. When the voltage will exceed from 5.05, it will change the variation. So this feedback will ensure the availability of the voltage at this position 5 volt. This PWM controller IC is driving this switching device at high frequency, 50 kilohertz, 60, 100. What that means, this is one switching cycle, 1 hertz. Then other cycle, this is one cycle. So this IC will provide, for example, 50 kilohertz. That means 50,000 hertz. It will turn on or turn off this switching device. When it will turn on, it will give high signal. When it will give high signal, at high pulse, this transistor will switch and it will allow to current flow in this transformer. We will receive output. When the voltage are maintained here, this feedback loop will reach to this PWM controller, and PWM controller will become to know that voltage are maintained. If the voltage will increase, what it will do? It will control the magnetic field of this transformer. How it will do that? It will reduce its duty cycle. It will turn on this transistor for little time, for shorter time. So less magnetic field will be created in the winding. We need a little amount of voltage to replenish this capacitor, because this time we are not connecting load. If the voltage will drop, this IC will become to know that voltage are dropped. It will increase its duty cycle. For each cycle, it will adjust turn on time vs turn off time. So this is regulation technique. If you connect load here, in first condition, there was no load. But if we connect load, for example, we need 5 volt 2 ampere. At that time, a little voltage drop will appear at this point. So this feedback network will sense that fall in the voltage. It will give feedback. So this IC will increase the duty cycle. One condition. If you connect 2 ampere load, there will more drop in the voltage. When there will more drop, this feedback will ask this PWM controller to increase the duty cycle, so it will turn on like this. This is on time, this is off time. So it will adjust its on time vs off time to control the current flowing in this section. So this controlled current will control the magnetic field. That controlled magnetic field will be transferred in the secondary. Secondary voltage will rectified and load regulation. It is called load regulation. When any power supply adjusts its duty cycle based on the load from no load to maximum load, it will adjust its duty cycle. It is called load regulation. If there is no load, it it will provide 5 volt. If there is medium load, it will provide 5 volt. If there is maximum load, it will provide 5 volt. By adjusting duty cycle, by controlling the current. This is one condition. The second condition, if we are providing 220 volt here, rectified voltage 310 volt, DC 310 volt, at that time a small switching cycle will cause to flow more current, because we have voltage I is equal to V over R. In this condition, R is equal to XL, inductive reactance. We are flowing this current in inductor, so XL. If we say I is equal to V over R, I is equal to V over XL. Here is XL. XL, inductor value and frequency. At high voltage, we need a short amount of turn on time to create required magnetic field. But now in other condition, if these voltage are dropped here at 100 volt AC, this 100 volt AC rectified, it will become 140 volt. This 100 volt will become 140 volt. At that time, we need more switching time, more wide turn on time to provide magnetic field in this winding, to maintain the voltage here. In that condition, this PWM controller will adjust its duty cycle to regulate this 5 volt. Our basic agenda to regulate 5 volt at output stage. Either this drop is due to load or drop in line voltage. If due to load, it will adjust duty cycle. If this drop is due to this drop, line drop, it will adjust duty cycle. In both cases, line or load, if the voltage will drop at this point, it will adjust duty cycle. It will increase duty cycle to increase voltage. If the voltage are becoming high, it will decrease duty cycle to decrease voltage. That increase, maybe if we remove load, the voltage will increase. Or if there were 100 volt, suddenly the voltage are increased to 220 volt, the voltage will increase. Why? If using same switching cycle, if it is working at 140 volt, line increased, voltage increased to 310 volt, it will double the magnetic field, so there will more voltage in output. But no, this IC, this PWM controller will adjust its duty cycle. This is flyback technique. It is used for low power loads. 5 volt to 2 ampere, that means 10 watt. If we see here is a switch to compensate this variation. If we are operating this power supply at 220 volt area, at that time maybe 185 to 245 volt, this PWM controller can adjust its duty cycle and it will provide regulated output. If the voltage will drop than 185 volt, maybe this power supply will lose its line regulation, because line voltage are dropped. Why? Because we are taking 250 watt output. So in that case, this IC will fail to regulate the voltage due to line loss. For that purpose, this switch is used here. If we are operating at 110 volt, at that time line voltage will be regulated at DC rail. So we will take regulated 250 watts output. This is cheap design. If you see this delta power supply, it will receive line voltage here, rectifier, then these voltage are passed to this PFC choke, PFC inductor, then a rectifier. Here is some switching device. If you see this transistor, it is connected between positive line and ground. Either it is MOSFET, IGBT, transistor, whatsoever. It is being controlled by PFC controller. PFC controller IC will sense the voltage present at this line input voltage. It will sense the voltage here at this capacitor. It will compare these values and it will drive this PFC circuit MOSFET. It will turn on this MOSFET and it will switch here. When it will switch, it will make a short circuit on this DC rail. Voltage positive and negative here. This turn on for very short time will create a surge current in this core. So it will store energy in this inductor, then this MOSFET will turn off. When its stored magnetic field will collapse again, so its reverse EMF will become opposite in direction. Before this end was positive. In result, this end will become negative, this end will become positive. If 310 volt here, in case we are providing 220 volt, 310 plus 80 volt from here will be rectified because this diode is forward biased now. We will receive 390 volt here at this capacitor. If we check this circuit, here this PWM controller was adjusting its duty cycle with line drop or with load drop. But here this PWM controller will become free from line drop because we are providing regulated voltage at this point. That is this area. So in this design, this line variation on DC rail is finished because we will provide this 390 volt. If the voltage are dropped here until 100 volt DC, we need 390 volt here at this point. 390 minus 100, so we need 290 volt to produce 390 volt. When this line was at 220 volt, it was switching for low time like this. When the line is dropped, it will turn on this transistor for long time to store more energy in this core. That is this one. And in result, 100 volt from line and 200 volt created from this choke, this inductor, will provide resultant output at this capacitor. So we will regulate the line voltage at this capacitor. This PWM controller will just only adjust the load regulation. So the duty of this PFC controller is to compensate the line loss. If the line is varying from 85 volt to 245 volt, 260 volt, this PFC controller here will switch this MOSFET to store energy, then this energy will be rectified, then this energy will be rectified by this rectifier and we will receive voltage at this capacitor positive terminal. PFC controller will maintain 390 volt at this point. Then the next duty for this SMPS controller, PWM controller, it will switch these MOSFETs, and these MOSFET will drive these voltage 390 volt to this transformer, and we will receive regulated output voltage. So this is the function of this PFC controller. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.